Hi students and welcome to lesson 2 for 8th grade. Open to this page in your book. We're being asked to draw out some squares based off of here represent one square unit. So for square 1, the area is only one square unit. So it would be this, like this guy. And one side length is 1 unit. So then for square 3, it wants 4 square units. And because this is going to be a square, we know that we need to kind of draw it like this. It's going to be 4 square units. And so one side length, like this side right here, is 2 units long. So it's going to be 2 units. So now they're asking us if we can do the same thing with an area of 2 square units. So let's write out some of the ways we can draw 2 square units. We can draw it like this, but that's not a square. We can draw it like this, and that's not a square. Well, in here we know that this was 1 square unit and this was 4, so 2 is going to be somewhere between 1 and 4, so we could go and do something like this. Well, it's going to be bigger than 1 but smaller than 4, so maybe it would be like this. But we can't tell exactly how many squares that is. So it says describe any problems we have. Well, square 2 is a problem because we can't find exactly the side length when the area is 2 units. All right, so we're going to talk about 3 vocabulary terms for this lesson, and you can see them over here on the left of your screen. So square roots is the first one we're going to talk about, and this is one you've probably heard about before. So the square root of a number. And if you think about the term square root, why it's actually called a square root is because it's the root of a square. It is how long that side length is when you're looking at a square. So remember in the square, I'm drawing it a little bit bigger here, but the square that had an area of 4 square units, the square root is 2 because it is 2 units long along the side. So the square root, which we represent with this symbol right here, the square root of 4 is 2. Okay? And whenever you take the square root of a number and you get a whole number, that is called a rational square root. So that's going to fall under this category right here. But if you were to take the square root of a number like 5, let's try the square root of 5, you're going to get a strange number. And I'm going to show you what that is on the calculator. So I'm going to do 5 square root. You're going to get this kind of number. So we can write that as approximately, oops, it's not the approximate sign, as approximately 2.236. But this is not the exact number of the square or the exact decimal form of the square root of 5 because the square root of 5 is considered an irrational square root. It's a square root that is not a perfect square, which we'll talk about in a moment, and therefore it's going to have a decimal form that goes on and on and on and on and on forever and never is going to have an end. So irrational square roots are decimal forms that never have an end. So just a moment ago, you heard me mention perfect square roots. And we can make a list of perfect squares by just making a number line here. So we're going to say our numbers are 1, 2, 3, 4, 5, 6, and so on. You can continue these numbers on your paper. So what I'm going to do is I'm going to say, I'm going to square each of these numbers. So 1 squared is 1, meaning 1 times 1 is 1. 2 times 2 is 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. And so on and so forth. There'd be 49, 64, 81, and 100. These are all examples of perfect squares. And we call them perfect squares because if we were to take the square root of them, we would get a whole number. The square root of 9 is 3. The square root of 25 is 5, and so on and so forth. So we can take these numbers, take the square root, and they would be a whole number. So they are a rational number. So here we're asked to determine whether or not the square root is rational or irrational. So basically they're wanting to know, is the square root of 9 on our perfect square list? Well, let's go back and look. Here's the square root of 9. The square root of 9 is 3. So that is going to be a rational number. We'll drag it over here. The square root of 8. Is 8 on our perfect square list? Nope, it's not. So 8 is going to be an irrational number. The square root of 8, I should say, is an irrational number. Square root of 7 is also not on our list, so that's going to be irrational. Square root of 6 is irrational. We already checked the square root of 5 is irrational. 4, I believe 4 is on our list. Yep, because 4 is 2 times 2. So 4 is a rational number. Oh, come on. Oh, it does not want to stay over there. Okay, well the square root of 4 does not want to stay over on the rational side, so I'll hold it here for a moment. And then the square root of 3 would be irrational as well. All right, so now, oh, there it stays. Irrational. Square root of 2 is irrational, and now we can check it. So now it's time for you to try the first Got It in your student companion book. Choose which numbers here are irrational, and if you don't know, please go ahead and get a calculator and check it. All right, so the square root of 25 is 5, so it's a perfect square, and that's rational. The square root of 50 is not a perfect square, so it's irrational. And the square root of 125 is not a perfect square, so that is also irrational. All right, so the second part of our lesson today, we're talking about other kinds of irrational numbers. And one irrational number that we see all the time in math is the term pi. Pi, we typically say, is 3.14, but we say that because we have to estimate its value because the actual number is all of these digits. And if we were supposed to be doing some calculations, it would be very hard to do calculations with all of these digits. So let's go ahead and watch this little video here.
Harry, what were you thinking trying to memorize all the digits in pi? It doesn't terminate, it doesn't repeat, and there's no pattern. Rational numbers have decimal expansions that terminate in zeros or eventually repeat. Irrational numbers cannot be represented as terminating or repeating decimals. Irrational numbers also include non-repeating decimals that have a pattern in their digits. Since pi is an irrational number, the decimal digits do not terminate or repeat.
Okay, so irrational numbers are never, ever, ever going to repeat, and they're never, ever, ever going to end. And they also include these numbers where you're going to see 1, 0, 1, 0, 0, 1, 0, 0, 0. These are numbers that are in a pattern, but the actual number is going to go on forever, so it is still irrational. So now let's check and see if each one of these is rational or irrational. So 2.125. We don't see any of the repeating dots or repeating bars. And if we saw anything like that, that would trigger that we need to look at it closer. And since there's nothing, we're just going to say it's rational. This one is 2.11111, and the dots mean that it goes on forever. But since that 1 is repeating itself multiple times, it's repeating in a pattern, and that repeat means that it is rational. This one we have 2.01011101110111. It's repeating in a pattern, but it's not a pattern that we can draw a repeat bar over, so it's irrational. This one is 2.12341234. It's repeating in a pattern, and if we were to draw a repeat bar, we would draw it over the 1, 2, 3, 4, so that's rational. And then this one is 1.803333, and the 3's repeat and keep going. So because the 3's keep going in a pattern, that is also rational. So in your book, try this got it. Which number is not irrational? Assume each pattern continues. So which one would not be irrational? All right, so the first one is showing a pattern, but it doesn't have a repeating pattern or a terminating decimal, so it's irrational. The second one is a repeating decimal with a repeating pattern, so it is rational. And the third one is a pattern also, but doesn't repeat, so it is irrational. All right, so now we're going to talk about different types of rational and irrational numbers and what terminology we can use to describe them. So we're going to watch this video together, and then we'll pause it as it goes so we can keep talking about it.
The first set of numbers you learned about was the natural numbers. These are also called the counting numbers.
So when you were learning how to count and you were counting 1, 2, 3, those are natural numbers. They're numbers that we count, like when we're counting objects.
The natural numbers, together with the number 0, form the whole numbers.
Okay, so then we also can say that any whole number is any natural number, including the number 0. So just like our counting numbers, 1, 2, 3 are natural numbers, they're also whole numbers, and 0 is also a whole number.
So all natural numbers are also whole numbers. The integers are the set of positive whole numbers, their opposites, and 0. So all the whole numbers and the natural numbers are integers.
Okay, so the natural numbers and the whole numbers are also integers. But integers are not necessarily natural numbers, and they're not necessarily whole numbers. But all of these types of numbers are also integers.
The rational numbers are the set of all numbers that can be written in the form a divided by b, where a and b are integers and b is not equal to 0. So all integers, whole numbers, and natural numbers are also rational numbers.
Okay, so we have the natural numbers here that are all able to be written as a fraction. The whole numbers can all be written as a fraction, and integers can all be written as a fraction. Therefore, all of these numbers are all rational numbers.
And irrational numbers are numbers that cannot be written in the form a divided by b, where a and b are integers and b is not equal to 0. Together, the rational and irrational numbers form the set of real numbers.
Okay, so real numbers is what we call all the types of numbers. And then inside of real numbers, you have either rational or irrational. Inside of rational numbers, you have all these other types of possible numbers inside of rational. Okay, so with all that information, let's go ahead and try the got it in your book. It says, what are all the possible names for 1 and 2 ninths? So is this a real number? Is it a rational number? Is it an integer? And so on and so forth. So let's jump back to this chart that we were just looking at, and we are looking at the number 1 and 2 ninths. So 1 and 2 ninths, when you're learning how to count, do you count 1 and 2 ninths? You don't count that, so that's not a natural number. 1 and 2 ninths is not a whole number because it's 1 and 2 ninths. It has a fractional part with it. And then 1 and 2 ninths, is it an integer? So an integer is a whole number that is also negative. So even though this is written as a fraction, this is negative 10 over 5, which is negative 2. And this is the negative square root of 16, which is negative 4. So these are actually whole numbers in disguise here. So our number is not an integer. It is just rational, and it is a real number. And so we'll check our work. We're correct there. Go ahead and do numbers 1 through 3 in your close and check, and then come on back to check your work using these answers. Pause the video to check your work.